So a squared plus b squared equals c squared, right? So a and b, I want to kind of come up here. A and b are the legs, and c is the hypotenuse, okay? Okay, so always know that c is the hypotenuse. So that's the square of the legs equals the square of the hypotenuse. Okay? And then there's another little rule that we haven't really talked about, but we're going to talk about just a little bit today. It says the theorem works both ways. So it says if a triangle is a right triangle, then a squared plus b squared equals c squared. Also, if a squared plus b squared equals c squared, then the triangle is a right triangle. So it doesn't have to, I can just have the leg, they can just give me the legs of a triangle and say, is it a right triangle? I put it into Pythagorean theorem. If it equals each other, then it is. If it doesn't, it's not a right triangle. And we're going to have an example of that in just a minute. Hi, Yatsiri. How are you doing, honey? Where are you at? Oh, there you are.
Oh, I'm Jasmine.
Oh, sorry. Jasmine A, right?
Yeah.
There we go. Sorry, sweetheart. Okay. Do you want the notes?
Yeah.
There you go. So here we go. We have a few examples. So the first one, it just says find the missing side, right? So the first thing I need to do is identify my hypotenuse. Which one is the hypotenuse? X, 8, or 13? 13 is my hypotenuse, right? I'm going to look at my right angle sign, and it draws an arrow towards the hypotenuse. So that means this would be x squared. So this is my hypotenuse. This is a leg, and this is a leg. So x squared plus 8 squared equals 13 squared. And now I'm going to solve for it. Hi, Mateo. So I've got, do you want the notes? Okay. So I've got x squared plus 64 equals 169. Whew, okay. Then I want to get the x by itself, right? So I'm going to subtract 64. And I get x squared equals 105. And then how does x squared become x? How do I change an x squared into an x?
You divide by that?
Nope, I don't divide. Because divide is opposite of times. Am I timesing? No. How do you undo a square? Does anyone remember how we undo a square?
I forgot.
We do this. We take a square root, right? So if I square root one side, I'm going to square root the other side. So that means x is going to be approximately equal to, now I'm going to got to get out my calculator.
10.246950.
10.24? 24 what?
69.
So 10.25. We're just going to round it to 2 decimal places. Okay? Is there any questions on how that works? Not too bad, right? Okay, so the number 2 says find the diagonal. So that means I want to find this one right here. This happens to be a right triangle, right? Right triangle. So I'm going to use a squared plus b squared equals c squared on it. Which one is my hypotenuse?
In that middle.
The middle part. This is a right angle, right?
Mm-hmm.
So where's my hypotenuse at?
The line going across the middle.
What I'm trying to look for, okay? So then I have 4 squared plus 11 squared equals x squared. So let's see if I can figure this out. 16 plus 121 equals x squared. 137 equals x squared. How do I get the x squared to go away? Square root it. Great.
11.7.
11.7. Is that an approximately? Of course it is. Equals x. Okay. Questions? Home? People at home? My Zoomers? You guys doing okay? The Zoom club? Awesome. Okay. And then this last one is the reverse. It says, is this a right triangle? And it just gives me the side lengths. How do I know which one's supposed to be the hypotenuse? 16. Remember, we said it's the longest side, right? So this one is going to be C. So this one's going to be A. It doesn't matter. Does it matter which one's A or B? No. So I'm just going to say this is A, this is B, and this is C. So 8 squared plus 10 squared should equal 16 squared if it's a right triangle. If it's not, then it's not a right triangle, right? So 64 plus 100 is supposed to equal 256. So does 164 equal 256?
No.
No, not a right, R-I-G-H-T, right triangle. Okay, so it's not a right triangle because a squared plus b squared does not equal c squared. If they did equal c squared, then it would be a right triangle. Does that make sense? Okay. So now we have some examples. We just want you guys to find the x on these. So I want you guys to spend some time, a few minutes. I don't know how many minutes. There's 6 problems. Let's do, so if I'm on A, right, I got the hypotenuse. This says 5.4, oh, so sorry. Clear. Let me erase this. It says 5.4 squared plus 8.3 squared equals x, right? So then x squared, sorry. And then to find x, I'm going to take the square root of this. So in my calculator, I just put this. I put x equals the square root of 5.4 squared plus 8.3 squared. Okay, so I put that in my calculator and I got x is approximately equal to 9.9. So I can put this whole thing into my calculator. I don't have to find out what 5.4 squared is and 8.3 squared is. I can put the whole thing into my calculator and find out what it is. Does that make sense?
Yeah.
Okay. Okay, guys, here we go. So for B, here's my hypotenuse, right? Right here. So I've got x squared is going to equal 4.6 squared plus 3.9 squared. Take the square root of it. So I'm just going to put that into my calculator, and I'm going to get x is approximately equal to 6.03.
For what one?
B. Okay. And then for C, here's my right angle, so it shoots towards the hypotenuse. So that means I've got x squared plus 1 squared equals 5 squared, or x squared plus 1 equals 25. Subtract 1, x squared equals 24. Square root both sides. And x is approximately equal to 4.9. Let's see. Number D. Again, locate your hypotenuse. Shoots towards my hypotenuse. There's my hypotenuse. So I've got, let's do this over here, x squared plus 3.7 squared equals 6.2 squared. I'm going to subtract 3.7 squared. So I've got x squared is going to equal 6.2 squared minus 3.7 squared. Square root it, put that whole thing into your calculator, and I'm going to get x is approximately equal, what letter are we on? D, 4.97. So I'm not going to tell you that you can't write out the, like, I can't do x squared equals 13 x squared plus 13.69 equals 38.44, right? I square these out, and then I subtract 13.69, and I get x squared equals 24.75, and then I square root it. I'm still going to end up with this answer. You can do that. I can square out the decimals. I just sometimes find it's easier just to leave them in the squared form, especially when I know I'm going to use my calculator, and just put it all into my calculator in this form here. So sometimes I just find it easier just to put it in this form instead of having so many decimals that I have to enter into the calculator. Does that make sense?
Yeah.
So sometimes I just like putting it all into that, in that form right there, because it sometimes tends to be a little easier, and then I'm not making as many mistakes on my calculator entry. Does that make sense?
Yeah.
Okay. So because I can manipulate the numbers just like I have here and with the squareds. Okay.
Yeah.
Okay. So number E here, find your right angle. Oh, sorry. Let's try this again. Find my right angle. Here it is. It points towards my hypotenuse. So that means I've got x squared plus 5.4 squared equals 6.6 squared. So if I subtract 5.4 squared, I'm going to end up with x squared is going to equal 6.6 squared minus 5.4 squared. And I find the square root of that. X is approximately going to be equal to 3.79. Okay?
What's the definition of
Yeah, but that doesn't get turned in. It's just an assignment.
It's assignment in Canvas, not Delta Math today. Okay, and then the last one, again, I want to find my hypotenuse. There it is. So I've got x squared plus 5.9 squared equals 7 squared. And if I subtract 5.9 squared, I'm going to get x squared equals 7 squared minus 5.9 squared. And I square root both sides. Why do I have a timer on? That's so interesting. X is going to equal 3.8 approximately. Okay? So any questions? I know we've done the Pythagorean theorem before, so this is basically just a review of the Pythagorean theorem before we start trig. And we're doing trig because remember on the 29th? 29th is your Aspire test, right? That you need to take. All 10th graders need to come in and take the Aspire test. Okay.